Hey everyone, today we're gonna be doing a Leetcode question which is to find maximum area in the rectangle. So they are asking like they are given some grid. This is some grid having only ones and zeros. We need to find the largest rectangle considering like every one should be there. If I say if this is a grid, every like connected one should create one rectangle. So we need to find what is the largest rectangle we have. So let's see like what else it is given. So they are saying okay, length of the matrix and like the row and column will be like from one one element to like 200 elements. If you see in this grid, I can have from 1 to 200 element in the row and the column as well. And the matrix only consists of zeros and one. So let's see like what is this question is asking, like what to do and how to do. So let me draw this grid. So if I say this is our grid, 1, 1, 1, 1, 1, 1, 1. Also we are given 0, 0, 1 and 0. Again 1, 1, 1 and 0, 0, 1, 1 and 1, 0, 1, 1 and 0. So this is some grid. We need to find like what is the maximum rectangle we are getting or consisting only ones. So if you see this alone can be one rectangle. Similarly, if I say what else I can have? I can have each and every single ones can be a rectangle. Similarly, this whole can be a rectangle. This alone can be a rectangle. This can be a rectangle. This can be a rectangle, and single element can also be a rectangle. So if you see here, the maximum rectangle is of size 6 here. You can say if this is a rectangle, it is like 1 cross 4. If you see this is the maximum rectangle, this is 1 cross 5. If you see this is the maximum rectangle, this is 1 cross 3. So what we are saying, we need the maximum rectangle. If you see, if I say, okay, this particular rectangle having same column, you can say same height and same width, I'll say, okay, this is a rectangle of 2 cross 3, which is 6. So we are asking like, what is the maximum rectangle you can create from this grid? So if it is like if you see we are given some zeros and one, what we can do if you see the basic idea, what I can do, I can start from this like iterating from this grid of zeros and ones, and I can check okay, let me know the connected ones. Let me know the connected ones. So if I start from here, I have my connected one as this, and like for this is a connected one, but this is not a connected one. So I'll say, okay, maximum rectangle for this particular row, it will be 1. Similarly, if I go down, 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 I'll get maximum rectangle like this much. If you see, I'll iterate over each and every column in a brute force manner, and I'll say, okay, let me know the connected ones. So for iterating this single element, I need row cross column as a time complexity. Like I will be looping for every row, I will be looping column by column. Okay. I mean this character I'll just loop. And again for that character, I'll see the connected ones. So if I say, okay, for this particular one, I need to check whether it is having the connected ones, the next one and the next one, it should be 1. If you see for this element, it is 0 and 1. If you see this element, this is 1, this is 1, this is 1, but this is not 1. So I'll say, okay, I cannot go up, but I can go left and right. So this can be my potential answer. So I'll go till the extreme. So if you see what we are doing something like recursive brute force search, or you can say we are doing some backtracking or some DP approach. But there is one catch. They are saying I need a rectangle. If you say if I start looking for the next one, the connected one, it can go till like if you see for this example, okay, I'll say okay, this is my next one, this is my next one, and for this it is next one. So it is giving me number of ones. If I say if I use the recursive approach, it will give me the number of ones. But I need a row and column, like it should have a complete one. So I cannot use something like recursive solution or the backtracking or the dynamic programming because I just need a connected ones. Okay, or each and every cell should be connected. So if you see, this is like if I say if I break down this question into some part, so there's one famous question. I'll say area in histogram. Okay, so we have some famous question. I have some area, the histogram question, where what we need to do, we need to find if something is given in a height bar. If I say, okay, I'll say this is some bar. I have some heights. I have some height like of like 2 or 1 or 0 or 3, something like I'll say, or let me take any of the example. Okay, let me take this alone. So suppose I have something like this. Again, I have something. Let me say I have this much only. So let me mark this like, okay, this can be 2, this can be 1, this can be 0, this can be 3, this can be 1. For now, I have just taken some example. So if I wanted to mark, okay, let me say I have one more. Let me mark one more to create maximum rectangle. So I'll say, okay, this will be of length 2. Okay, I have some rectangles. So if you see, if I wanted to know the rectangle, like maximum rectangle creating using this histogram. So if I say, okay, for this particular alone, my width will be 1 unit. Okay, my size of this will be 1 unit and the height will be of 2 units. So I'll say, okay, the area by this particular bar will be 2 units. If I say, okay, if I create this particular histogram, so my maximum height can be 1, my width can be now 2. So in this case also I am getting my area as a 2. Like if you say 1, you can say 2 cross 1, or you can say 2 cross, yeah, maximum height is 1. So I'll say, okay, 2 is the breadth, height is 1. So I'll say, okay, 2 cross 1 is the area of this particular rectangle. I cannot include this one because this is a minimum. If I say I have breadth as a 3, but I have my height as 0, so it will give me the 0. So what I'm saying, I need something which is common to all. If I say, okay, for this alone, if I say it is having 2 cross 1 as a height, and for this it is having 1 cross, like, see, for this one it was 2 cross 1, and for this also it is 2 cross 1. It is not 2 cross 1, it is like 1 cross 2 because we are increasing our breadth. If I say height into breadth, it will be height is 1 and breadth is 2. Okay. For this alone it's empty. For this alone it is 1. If I say for this alone it's 3. If I say if I include this one or if I include this one, okay, what, like how much I can include? I can include till the maximum element. Okay. If I say for this element, I have my height as a 1, but I have width as a 3. So I can say, okay, this can be my area of histogram, like this can create one area. So let me take the good example. Like if I say, what if suppose this was some histogram? Let me say, okay, just ignore this part. Like considering this part, if I do the sum, like this is some histogram, then including this can be a histogram, and then including this can be a histogram. So what I'm saying, like if I say, for now, if I say, okay, let me create a map over here. Okay, for this case alone, my histogram will be like 0, you can say 1 0 1 0 0. So I can say, okay, area can be maximum 1 from here, 1 from here. So either one can be like maximum area can be 1 from this bar. You can say this is some bar, like I have this bar, then 0, then 0, then 1, then 0, then 0, then 0. So I have this as a histogram for now. What if I include this one? So my area, you can say my bar size gets increases because this is 1, this is 0, this is 1, this is 1, this is 1. So I am just including 1, 1, 1. So if I say for the next case, for the next one, I have my histogram size as like 2. If I say for now, if I consider this alone, okay, for this alone, I have this as a height. For this, I have 0 height. For this, I have 2 height. For this, I can say, okay, I can have minimum or you can say maximum 1 height. So I'll say, okay, if I include all of them, so I have my initial map like this, then I included 2 again, then I included 1 and the 1. So I came like I included this here, I came 0 here, I included this as a 2 here, I taken the sum 1 here, sum equals to 1 here. If I create the histogram for this, it will be like something like 2 units, then 0, then again 2, then I have 1 units, then again 1 units. So if this is my histogram, what maximum height can I, you can say, what is the maximum area I can get. So I can get this as a maximum area of 2 cross 1, like 2 is the height, 1 is the breadth. I can have 3 as well, like this is like 1 unit of height. I'll say height is 1 unit, height equals to 1 unit, but breadth is now 3 unit. By 3, because if you say for this breadth, minimum can be 1, like you can say at least there will be one height as a common. If I having this as a histogram, this as a histogram, then this as a histogram, so I'm getting like one height as a common between them. So I can say, okay, there will be one height common, and how much size can be there, like how much width can be there, till what element it will be common. I'll say, okay, 3. So it can be my 3 as an answer. Similarly, if I include this as well, so when I will include, when I get 1, I'll just say, okay, just increment or just add 1. For this, I get 1, I'll say, okay, for now, just increment to the above result. For this, I'll say increment to the above result. For this, I'll say, okay, include to the above results. I'll say 2 and 2 here. For now, I have this as you can say some, you can say bar. So I'm just like using this approach. You can say I have some histogram given in an array like this 2, 1, 0, 3, 1 and 2. This is some histogram. What we are saying, I just need to find the area between that histogram. So if I'm just tell, for this, I have some height as a 3, then I have 1 height, then again I have 3 height, then I have 2 height, then I have 2 height. If you see for this case, maximum can be this 3 into 1. Then for this I can have 2 into 1. For this I also can have how much? Like if you say I have 1 cross 5, like I can have minimum 1 common. If you see 1 is common between all, so I can say, okay, 1 into 5, because the width is 5, I can have 5 as an element. For this, if I say, okay, this was our histogram, okay, this is our histogram. For this alone, if I say this is 3 unit, this is 2 unit, this is 2 unit, 2 is common between these two, this 3. So I can say, okay, 2 is the minimum height which is common, and I have 3 as a breadth. I have 2 common between 3, so I can have 2 into 3 as a 6 area. So let me like explain how this area of histogram works before. So for getting this, if I say, if I take this example, okay, the third one, I'll say, okay, for this one, like including this all, I'll take this one 3, 1, 3, 2, 2. Okay, suppose I am given some array. I have some array 3, 1, array 3, 1, 3, 2, and 2. This is some array. We need to find the area between the suppose this is some array of a histogram. So let me create a histogram first. So I'll say, okay, our histogram can be of, I'll say, okay, this is our histogram. Let me take one example. Okay, so I have some bar. I'll say my height of the histogram can be, um, so initially what I have 3 as a height. Okay, for one case, I have 3 as a height. For another case, I have 1 as a height. So I have another histogram with height 1. Okay, another histogram again I have of height 3. Next histogram I have of a height 2. Next histogram I have a height of 2. So how much histogram I have? I have this 5 as this 5 bar, you can say. So I'll say, okay, for this height is 3. For okay, let me write it down. So for this height is 3. Let me mark up only. So I have height 3 for this, 1 for this, 3 for this, 2 for this, 2 for this. And I have some histogram, so I'll mark this as an index. I'll say, okay, this is your index 0, 1, 2, 3, and 4. So I have total how many histogram? 5 histogram. I need the maximum area between this histogram. So area means I need some of the rectangles. So I can take this alone can be a rectangle. This alone can be 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 rectangle. I can have the common part as well as the rectangle. So I have the height as 1, but I have width as a 5. So this can be my histogram. Again, if I say for this, how much is common? No, 3 is common till one place. Okay, let be it is it can have only 3 as a height. You can say area. If I say for this particular case, I can have maximum 2 as a height. for these three cases. So I can say with this three, like three elements are contributing with height 2. I can say area can be 6. For this also, my maximum, you can say common height, minimum common height, you can say it can be 2 until how much? Till 3 characters. So what I'm saying, like we are just finding the area between some bars. We are given some array. We are finding the area. I can say rectangle, you can say this is a rectangle, or this can be a rectangle. So if I say, okay, I have one rectangle of this, okay, again I have some rectangle of this, so I need to find like what is the rectangle giving me maximum area. So what I can say, okay, just create that array, iterate over this array, and give me the maximum area contributing via this array. So what I can do, I can use the stack approach for creating this area. So if you see how much, if you see here, if I have this area, I need to know if I have this as a common, how much I am getting the common part. So if I wanted to know what is the common part I can get with this particular bar, or using this particular bar, how much height, how much common height I'm getting. So for getting how much common height, I just need to find the previous minimum height. So if you say for this case, how much common height, I'll say okay, more than this one will be the common height. If I say for this, I'll say okay, more than this one, more than this one. Like for this, I just need a minimum height from this, minimum height from right. So minimum height from right, minimum height from left. I'm just need one plus then the minimum height. So if you see, if I have this case, if I mark this again, this is a array. I have some array. Okay, I have array 3, 1, 3, 2, and 2. If I wanted to know which element, if you say what is the height minimum to this, like minimum to this will be, you can, I just founding the boundary. If you see, I'm just founding the boundary like how much this one will be contributing. So it will be contributing till the more than the this element. So I just need to find what is the element we have more than this one. Okay, what is the element I have more than this one. So finding for more than, I can find the first minimum. If you see more than, I have this also, I have this also, I have this also. But if you see, if I find something minimum than this, I can say, okay, minimum than this, one greater than the minimum will be the element which is common to this. If I something like 0 over here, if I say I got one minimum 0 over here, so I can say more than this 0 will be contributing over this array. So what I need to find? I just need to find the minimum from right, minimum from the left. Okay, so I'll say okay, minimum for 3 will be what? 0. If I say for minimum will be 0 for 3. For 1 also minimum will be 0. For 3 I can say okay, 1 I can have as a minimum. For 2 I can say okay, 1 I can has a minimum. For 2 also I can have 1 as a minimum. This is, I'm going from left to right. So I have left smallest. I can also have right smallest. So I'll say okay, right smallest means for 2 there is 0. For 2 also it is 0. Like how many element? I'm not having any element which is maximum minimum than this. For 3 I have this 2. So I can say okay, for this I have 2 as a minimum. For 1 I don't have any minimum. So I'll say 0. For 3 I have nearest minimum like 1. So for this particular case I have nearest minimum 1. For this one I don't have. For this is nearest this. For this nothing. For this nothing. So I'm just noting out my minimum. After this minimum, if I have something here, so I can say this will be contributing more than one minimum. I have something minimum over here, minimum to 1. I'll say okay, more than one minimum will be contributing to this array. So anything greater than the minimum for this will be contributing over this array, or you can say histogram. So what I'll do, I'll contribute this one using, like I have some left minimum, right minimum. I just need to find how much it is contributing. I can say okay, just find the minimum from here, minimum from here. Before this minimum, after this minimum will be my common part. Okay, I'll say common part will be something greater than the minimum for this, something greater than, if I say for this case, my minimum is first, for this minimum is first, I'll say okay, more than this, more than this and less than this. So I have this as my common part alone. If I say for 2, I have left minimum as infinity and right left minimum as 1, right minimum as infinity. I can say okay, more than this will be my this element, more than this will be my this element. So I'll say okay, this can be my common part. Okay, so what I need to do, I need to find the left and right minimum for both, nearest minimum. So for finding the next minimum, what I can say, I can use of a stack. So using the monotonic stack or normal stack, I can get the nearest minimum or the maximum for any of the number. So if I have this as my minimum, okay, I have this as a minimum, I just need to find the left minimum. I'll say okay, left minimum, left smallest. I'll say okay, I start with some stack. I have 3 as a minimum. I will remove any element which is more than my current element. For this, I don't have any minimum. So for first element, I'll say okay, minimum will be 0. Or let me mark this as an index. I'll say -1 if I don't have any minimum out of bound. I'll say okay, this is some out of bound condition. I don't have any minimum for this particular case. Okay, I'll append my 1 and I'll remove all the element less than the greater than the current element. So if I append 1 in the stack, I'll say I need to pop the 3 from here, then I'll append my 1. Okay, now my minimum is 1, but for 1 also I don't have any minimum. I'll say okay, -1. For 3, I'll say okay, remove all the element from the stack. If it is greater than 3, I don't have, I'll say okay, top of the stack will be the minimum. So for 3, I'll say 3 I got 1 as a minimum. Then I'll append 3. For 3 I got 1 minimum. For 2, I'll say okay, 2, just remove all the element greater than 2. Okay, I remove. Now my top of the stack will be 1, so I'll say 1 will be my minimum for this one. So again I'll append 2. I again got 2, I'll just pop this 2. I'll say what is the minimum? I got 1, I'll append the 2. So we are getting the index. So something not found, I'll say -1, out of bound condition. Okay, for 3, I gone out of bound. For 1 also I got out of bound. I have gone out of bound for this one, means I don't have any minimum. For this also I don't have minimum. For this I have minimum. For this I have minimum. For this I also have minimum. This is index because I just need to find the width. So we are just iterating over this and finding the width. Similarly, if I say for right, you can say right smallest. So if I say okay, I'll start from previous case. I'll say iterate from here. You need to find the minimum for you. So for now, it is out of bound. I can say so if it is out of bound, I can say okay, give the length of the array for now. Now if this is an array, I'll say nothing minimum than this, nothing minimum than this. So for now, I'm just giving the length of the array. For now, this is the number, minimum is 2. So what we are doing, we are just inserting this to the element, this to the element, and again I got 3, but from that 3 I have 2 as a minimum. Again for this I have what? This is the index 0, 1, 2, 3 and 4. So for now I have given my indexes 4 over here, means I have out of bound, like now I don't have any element, I gone out of bound. So I just append the 5 here. So 5 here, 5 here for these 2. Okay, for this 3 I have this element, means 3 I have as a minimum. This 3 index means second element. For 1, I have this second. For 1, I don't have, so I'll write 5 again. For 3, I have minimum as 1, so I'll write 1 over here. So I created one minimum, one maximum. So if you see, if you wanted to find how much element will be contributing toward this, so for this, I'll say, okay, give me the minimum from here, give me minimum from here. Just increase one. If you see, for this one, if I say for third, I'll say, okay, tell me the area contributing using this. So for this, I'll say, okay, my width will be, I have my width. Width will be what? Left side minimum for this element, I'll say index 2 and I'll say I got the minimum, I mean one element more than this minimum will be our element which is contributing. So if I say what I need to find, so I'll say okay, right minus left. This is how we are getting the length. So for this, I'll say right minus left plus 1. We do this for getting the length. But for now, right is what? Right minimum, right smallest of I, plus you can say minus 1, because we got out of bound like 5. I need to come to the last index. For this left, I got the minimum. So I'll say okay, minus what is left smallest of this index. Okay, left smallest for this index. Go one next to this. I'll say okay, plus 1, and we have minus 1. So at last we'll get this formula. And height we can say for this as a height. Now, if you see here, we got this as an area. I'll say okay, if it is common part, I just need to find the histogram for this. For this I can find the histogram. For this I can find the histogram. Okay, so for this histogram, what I can say, I just keep on finding the maximum area in the histogram. So let me write the code for this. Let me explain how we're gonna be doing this. So I might be having some area first. So let me create, like I will be finding the nearest smallest. So I'll say okay, there will be some function which is okay. Let me create function near small. Okay, so for each histogram, I will be for like finding the nearest smallest element. So I will be having some array. I just creating some function. It will be giving me the area. So I'll say okay. I'm just iterating from some steps. I have some boundaries. Boundaries means out of bound condition. So for the nearest minimum, let me write this skeleton. I'll explain this one. So for now, if you need to find the smallest minimum, I said okay, we need to use the stack. We can use stack to find the nearest smallest element. For this, I need some result as well. So what I need to do, I need to append something. So I'll say okay, for now none will be our smallest, and what the size. So I'll say okay, size of the array will be our result store here over here. What I will be doing, I will be iterating over the elements. So I'll say okay, for I in range, just iterate over the start to end position. Okay, start to stop position using some increment. So I'll say steps. Let me write this one. I'll say explain how this steps and all works here. All okay, yeah, fine. Now let me create this first. Then I'll say while we have stack, and the top of the stack, this element from the array. Okay, from the array means from the histogram array. So I have this as a histogram array. I'll say okay, the element more than equals to this, the current element. Pop that element from the stack. I just need the smallest for now. And this I will be appending to my result. So if I say okay, if I have the stack, if I have stack, I'll say okay, result of ith index will be the nearest smallest for this element. So I'll say top of stack will be nearest smallest. If it is not there, stack is not there, I'll say okay, result will be out of bound. Like I don't have any minimum for this. So I'll say okay, boundary will be our out of bound. Okay, at last what I'll say, just append the element, the current element to the stack. I'll say okay, stack dot append the ith element, ith index. At last I'll return my result from here. Okay, this is the function to get the nearest smallest element. Now I say okay, I have some matrix. This matrix, what I need to do, I need to find some area. I'll say initial area will be 0. Now I will be like iterating over the rows and like the entire array. So what I'll say, okay, I have some rows equals to length of matrix. How many rows I have? Matrix. Again, for column I have the initial start. I have some columns. Now, if I say for each row and column, okay. for each row and column. Let me create some histogram area also. So initially I have some histogram with 0, 0, 0 value. Okay, I'll say okay, I have some histogram with 0, 0 value. It will be equal to the number of columns. Now what I'll say, I have this, I'll iterate over the matrix. I'll say okay, for row in range rows, and for similarly for column in range columns. Now what I need to check, if the current matrix of row and column, if it is equals to 1, it means it is contributing to our this. If you see here, I have this matrix. If I say if this is 1, I'll say okay, increment this element, or you can say just +1 to the histogram area. I'm just sliding this bar. I'm just saying if it is 1, just include to my case. I'll say okay, histogram area, histogram of particular column will be plus equals to 1. Otherwise, if it is 0, I'll say that histogram also will become 0 for that case. I'll say for that column, histogram will become 0. Okay. Now, after each row, for that particular row, I have created my histogram. So for now, I just need to find the left smallest and right smallest. So I have left nearest smallest. So I'll say okay, left small, and I'll say okay, this I have some function for calling this near small. Now let me tell, like, we will be passing some array. Now if you are going from left to right, I'll say okay, start from 0, you can go till how much element, you can go till column. So I'll say you can go till boundary condition, like how many columns you have. Okay, this is our boundary condition. Like I can go till from 0 to size. You can say if you are looping in array, you can go from 0 to size -1. I'll say okay. Now how many steps I need to go? One steps. If something is not found, I'll say okay, append -1. If I'm creating element from right, if I'm getting the right smallest, now if you see, array will be same, but I need to run in a reverse logic. So I'll say okay, reverse will be column -1 will be the starting point. It will go till -1, then it will go like -1 step in a reverse order. If something is not found, I just need to find the out of bound condition, which is boundary of this particular case. Now if you have calculated your row, for each row I have some histogram. So I'll say okay, for column in range columns, just find the area between this histogram. Okay, so I'll say okay, height will be height equals to this histogram of column, and the width will be the position we are getting from, like, right smallest. This is our left and right smallest. I'll say okay, right minus left. So I'll say left smallest for that particular column minus left smallest for this column -1. Okay, I already explained like why we are using this as a function. Again, now I will be having my area as a max of area, and how much area this is contributing. I'll say okay, height HIGST HIGST, okay, into width UIDH. Okay, so this will be my area which is contributing using this particular histogram. At last, I will be returning this area. Return this area. So let me compile this code. Let me see whether it is running fine or not. So I can see matrix is not defined. So where I have given wrong. Okay, here it is matrix, matrix. Let me compile this again. I hope so. Okay, array is not defined. So where it is array? Here it is not array. Okay, it is histogram here. Sorry. So we have histogram as an array. So let me compile this again. Now, okay, one more mistake. There is no width. I have a spelling mistake. WIDTH. Compile it again. Now it is accepted. Let me submit this code. So as I can see, this code gets compiled successfully and it is submitted with very less time. For now, we have used the time complexity as like n cross m, or you can say row cross column, for iterating over this array or matrix. And for storing that element, I have used like size of a column. So this is all our code. Thanks for watching.